Dear students, Assalamu alaikum. Let's start lecture 21 of CS 317 Operating Systems. We are starting a new chapter called File Management, and we will be referring to chapter number 12 of the William Stallings book. Let us start the overview regarding file management. Files and file systems. From the user's point of view, one of the most important parts of an operating system is the file system. The file system provides the resource abstractions typically associated with secondary storage. The file system permits users to create data collections called files. Desirable file properties. Long-term existence. Files are stored on disk or other secondary storage and do not disappear when a user logs off. Shareable between processes. Files have names and can have associated access permissions that permit controlled sharing. Structure. Depending on the file system, a file can have an internal structure that is convenient for applications. In addition, files can be organized into hierarchical or more complex structures to reflect the relationships among files. Functions on files. Any file system provides not only a means to store data organized as files, but a collection of functions that can be performed on files. Typical operations include the following. Create. A new file is defined and positioned within the structure of files. Delete. A file is removed from the file structure and destroyed. Open. An existing file is declared to be opened by a process, allowing the process to perform functions on the file. Close. The file is closed with respect to a process so that the process no longer may perform functions on the file until the process opens the file again. Read. A process reads all or a portion of the data in a file. Write. A process updates a file either by adding new data that expands the size of the file or by changing the values of existing data items in the file. File attributes. Typically, a file system maintains a set of attributes with the file. These include owner, creation time, time last modified, access privileges, and so on. File structure. Four terms are in common use when discussing files: field, record, file, and database. Field. A field is the basic element of data. An individual field contains a single value such as an employee's last name, a date, or the value of a sensor reading. It is characterized by its length and data type. Depending on the file design, fields may be fixed length or variable length. Variable length fields. In some cases, the field often consists of two or three subfields. The actual value to be stored, the name of the field, and the length of the field. In other cases, the length of the field is indicated using special demarcation symbols between fields. Record. A record is a collection of related fields that can be treated as a unit by some application program. For example, an employee record would contain such fields as name, social security number, job classification, date of hire, and so on. Again, depending on design, records may be of fixed length or variable length. A record will be of variable length if some of its fields are of variable length or if the number of fields may vary. In both kinds of variable length records, the entire record usually includes a length field. In the case of variable number of fields, each field is usually accompanied by a field name. File. A file is a collection of similar records. The file is treated as a single entity by users and applications and may be referenced by name. Files have file names and may be created and deleted. Access control restrictions usually apply at the file level. That is, in a shared system, users and programs are granted or denied access to entire files. In some more sophisticated systems, such controls are enforced at the record or even the field level. Some file systems are structured only in terms of fields, not records. In that case, a file is a collection of fields. Database. A database is a collection of related data. The relationships that exist among elements of data in a database are explicit. You must have connected tables in databases using keys. When a database is created, we put a lot of effort in establishing relationships among the entities of the database. The database is designed for use by several different applications. A database may contain all the information related to an organization or project, such as a business or a scientific study. The database itself consists of one or more types of files. Usually, there is a separate database management system that is independent of the operating system, although that system may make use of some file management programs. Operations on files. Users and applications wish to make use of files. Typical operations that must be supported include the following. Retrieve all. Retrieve all the records of a file. This will be required for an application that must process all of the information in the file at one time. For example, an application that produces a summary of the information in the file would need to retrieve all records. This operation is often equated with the term sequential processing because all of the records are accessed in sequence. Retrieve one. This requires the retrieval of just a single record. Interactive, transaction-oriented applications need this operation. Retrieve next. This requires the retrieval of the record that is next in some logical sequence to the most recently retrieved record. Some interactive applications, such as filling in forms, may require such an operation. A program that is performing a search may also use this operation. Retrieve previous. It is similar to retrieve next, but in this case the record that is previous to the currently accessed record is retrieved. Insert one. Insert a new record into the file. It may be necessary that the new record fit into a particular position to preserve a sequencing of the file. Delete one. Delete an existing record. Sudden linkages or other data structures may need to be updated to preserve the sequencing of the file. Update 1. Retrieve a record, update one or more of its fields, and rewrite the updated record back into the file. Again, it may be necessary to preserve sequencing with this operation. If the length of the record has changed, the update operation is generally more difficult than if the length is preserved. Retrieve few. Retrieve several records. An application or user may wish to retrieve all records that satisfy a certain set of criteria. It should be noted that not all file systems exhibit the sort of structure discussed here. On Unix and Unix-like systems, the basic file structure is just a stream of bytes. A C program is stored as a file but does not have physical fields, records, and so on. File management system. A file management system is that set of system software that provides services to users and applications in the use of files. Typically, the only way that a user or application may access files is through the file management system. This relieves the user or programmer of the necessity of developing special purpose software for each application and provides the system with a consistent, well-defined means of controlling files. These are the objectives of file management system: to meet the data management needs and requirements of the user, which include storage of data and the ability to perform operations on it, to guarantee to the extent possible that data in the file are valid, to optimize performance both from the system's point of view in terms of overall throughput and from the user's point of view in terms of response time, to provide I/O support for a variety of storage device types, to minimize or eliminate the potential for lost or destroyed data, to provide a standardized set of I/O interface routines to user processes, to provide I/O support for multiple users in the case of multiple user systems. User requirements regarding files. Each user should be able to create, delete, read, write, and modify files. Each user may have controlled access to other users' files. Each user may control what types of accesses are allowed to the user's files. Each user should be able to restructure the user's files in a form appropriate to the problem. Each user should be able to move data between files. Each user should be able to back up and recover his or her files in case of damage. Each user should be able to access his or her files by name rather than by numeric identifier. Let us study the file system architecture as given by figure 12.1. At the lowest level, device drivers communicate directly with peripheral devices or their controllers or channels. A device driver is responsible for starting I/O operations on a device and processing the completion of an I/O request. For file operations, the typical devices controlled are disk and tape drives. Device drivers are usually considered to be part of the operating system. Moving up, we come to the basic file system. The next level is referred to as the basic file system or the physical I/O level. It deals with blocks of data that are exchanged with disk or tape systems. It is concerned with the placement of blocks on the secondary storage device and on the buffering of blocks in main memory. It does not understand the content of the data or the structure of the files involved. It is often considered part of the operating system. Moving up, we come to the basic I/O supervisor. The basic I/O supervisor is responsible for all file I/O initiation and termination. At this level, control structures are maintained that deal with device I/O, scheduling, and file status. The basic I/O supervisor selects the device on which file I/O is to be performed based on the file selected. It is also concerned with scheduling disk and tape accesses to optimize performance. I/O buffers are assigned and secondary memory is allocated at this level. It is part of the operating system. Coming up, we move to logical I/O. Logical I/O enables users and applications to access records. Thus, whereas the basic file system deals with blocks of data, the logical I/O module deals with file records. Logical I/O provides a general purpose record I/O capability and maintains basic data about files. The layer on top is the access method. The level of the file system closest to the user is often termed the access method. It provides a standard interface between applications and the file systems and devices that hold the data. Different access methods reflect different file structures and different ways of accessing and processing the data. File management functions. Now we will refer to figure 12.2. The first element here is the file structure. Users and application programs interact with the file system by means of commands for creating, deleting, and other operations on files. Before performing any operation, the file system must identify and locate the selected file. A directory describes the location of all files plus their attributes. Most shared systems enforce user access control. Only authorized users can access particular files in particular ways. Now we talk about records. The basic operations on a file are performed at the record level. The user or application views the file as something that organizes the records. Then behind records, we see blocks that are placed in main memory. File I/O is done on a block basis. The records or fields of a file must be organized as a sequence of blocks for writing to the device. The blocks of a file must be organized as a sequence of records or fields after reading from the device. And finally, at the back end, we see blocks in secondary storage. To support block I/O of files, we must allocate files to free blocks on secondary storage. We must manage free storage to know what blocks are available for new files and growth in existing files. Block I/O requests must be scheduled using a disk scheduling policy. File system performance. The optimization of a file system will depend on disk scheduling policy, file allocation strategy, file structure, and access patterns. Developing an optimum file management system from the point of view of performance is an exceedingly complicated task. Our next subtopic is file organization and access. File organization. We use the term file organization to refer to the logical structuring of records. The physical organization of a file on secondary storage depends on the blocking strategy and the file allocation strategy. What are the criteria to choose a file organization. In choosing a file organization, several criteria are important: short access time, ease of update, economy of storage, simple maintenance, reliability. The relative priority of these criteria will depend on the applications that will use the file. For example, if a file is only to be processed in batch mode with all its records accessed every time, then rapid access for retrieval of a single record is of minimal concern. A file stored on CD-ROM will never be updated, so ease of update is not an issue. These criteria may conflict. For example, to reduce size, there should be minimum redundancy in the data. On the other hand, we use indexes to increase the speed of access to data, and the use of indexes is a type of redundancy itself. Types of file organization. We discuss 5 file organizations: the pile, the sequential file, the indexed sequential file, the indexed file, and the direct or hashed file. Most structures used in actual systems either fall into one of these categories or can be implemented with a combination of these organizations. Now we look at the various file organizations one by one. The first is the pile. The simplest file organization is the pile. Data are collected in the order in which they arrive. Each record consists of one burst of data. Records may have different fields or similar fields in different orders. Each field should be self-describing, including a field name as well as a value. The length of each field must be implicitly indicated by delimiters or explicitly included as a subfield or known as default for that field type. A pile file uses minimal space and is easy to update because there is no order in records, so any new record can be appended to the end of an existing pile. Pile files are made when data are collected and stored prior to processing or when data are not easy to organize. Due to lack of structure, record access is by exhaustive search. If we wish to find a record that contains a particular field with a particular value, we must examine each record in the pile until the desired record is found or the entire file has been searched. If we wish to find all records that contain a particular field with a particular value, the entire file must be searched. It is unsuitable for most applications. The second file organization is called the sequential file. The most common form of file structure is the sequential file. In this file, a fixed format is used for records. All records are of the same length, consisting of the same number of fixed length fields in a particular order. Because the length and position of each field are known, only the values of fields need to be stored. The field name and length for each field are attributes of the file structure. One particular field, usually the first field in each record, is referred to as the key field. The key field uniquely identifies the record, thus key values for different records are always different. The records are stored in key sequence, alphabetical order for a textual key and numerical order for a numeric key. A sequential file is stored in sequential order of the records within blocks. That is, the physical organization of the file on tape or disk directly matches the logical organization of the file. Suppose a sequential file has 10 records. Each block on the disk can contain 2 records. Then the first 2 records are in the first block. The next 2 are in the second block. So the 7th record will be the first record in the 4th block. Sequential files are optimum for batch applications that involve the processing of all the records. For example, a billing or payroll application. Because no matter how large the file is, the code for processing every record is identical and easily written. To access a record, we need to do a sequential search of the file for a key match. If the entire file or a large portion of the file can be brought into main memory at one time, more efficient search is possible. Every new record must be added in the proper place according to key order. The usual procedure is to place new records in a separate pile file called a log file or transaction file. Periodically, a batch update is performed to merge the log file with the master file in correct key sequence. An alternative is to organize the sequential file physically as a linked list. One or more records are stored in each physical block. Each block on disk contains a pointer to the block containing the next record. The insertion of new records involves pointer manipulation but does not require that the records are in contiguous blocks. Thus, some added convenience is obtained at the cost of additional processing and overhead. I present to you the first task of this video. Can you use the binary search algorithm on a pile or a sequential file? Why or why not? Pause the video and write your answer in a Word file. A popular approach to overcoming the disadvantages of the sequential file is the indexed sequential file. The indexed sequential file maintains the key characteristic of the sequential file. Records are organized in sequence based on a key field. Two features are added: an index to the file to support random access and an overflow file. The index provides a lookup capability to reach quickly the vicinity of a desired record. The overflow file is similar to the log file used with a sequential file, but is integrated so that a record in the overflow file is located by following a pointer from its predecessor record. In the simplest indexed sequential structure, a single level of indexing is used. The index in this case is a simple sequential file. Each record in the index file consists of two fields: a key field, which is the same as the key field in the main file, and a pointer into the main file. To find a specific field, the index is searched to find the highest key value that is equal to or precedes the desired key value. The search continues in the main file at the location indicated by the pointer. In data structures and algorithms, we discuss that if we conduct a linear search in an array of n elements, the average number of comparisons required is n plus 1 whole divided by 2. Using this, we state that during a sequential search of a file containing n records, we need to make n by 2 accesses in the average case. To see the effectiveness of this approach, Consider a sequential file with 1,000,000 records. To search for a particular key value will require an average of 500,000 record accesses. Now suppose that an index containing 1,000 entries is constructed with the keys in the index evenly distributed over the main file. So each entry in the index points to a set of 1,000 records. Now it will take an average of 500 accesses to the index followed by 500 accesses to a set of the main file to find the record. The average number of accesses is reduced from 500,000 to 1,000. Additions to the file are handled in the following manner. Each record in the main file contains an additional field not visible to the application, which is a pointer to the overflow file. When a new record is to be inserted into the file, it is added to the overflow file. The record in the main file that immediately precedes the new record in logical sequence is updated to contain a pointer to the new record in the overflow file. If the immediately preceding record is itself in the overflow file, then the pointer in that record is updated. The index sequential file is occasionally merged with the overflow file in batch mode. The index sequential file greatly reduces the time required to access a single record without sacrificing the sequential nature of the file. To process the entire file sequentially, the records of the main file are processed in sequence until a pointer to the overflow file is found. Then accessing continues in the overflow file until a null pointer is encountered, at which time accessing of the main file is resumed from where it was left off. A search is unsuccessful when we get to the end of the file. To provide even greater efficiency in access, multiple levels of indexing can be used. The lowest level of index file is treated as a sequential file, and a higher level index file is created for that file. To understand, we assume a multi-level indexed file with two levels of indexes. Consider a file with 1,000,000 records. A lower level index with 10,000 entries is constructed. Each entry in this index points to a set of 100 records. A higher level index into the lower level index of 100 entries is constructed. Each entry in this index points to a set of 100 entries in the lower level index. The search begins at the higher level index, and using an average of 50 accesses, we find an entry point into the lower level index. This set in the lower level index of 100 entries is then searched using an average of 50 accesses to find a pointer into the main file. This entry points to a set of 100 records in the main file, which is then searched using on average 50 accesses. The average number of accesses reduces from 500,000 to 1,000 to 150 only. Pause the video again. Task number 2. Consider a file with 2,000,000 records. Find the average number of accesses for this file if no index is used, an index of 5,000 entries is used, two indexes, a higher level index of 50 entries and a lower level index of 2,000 entries are used. The index sequential file retains one limitation of the sequential file. Effective processing is limited to that which is based on a single field of the file, which is the key. For example, when it is necessary to search for a record based on some other attribute than the key field, both forms of the sequential file are inadequate. In some applications, the flexibility of efficiently searching by various attributes is desirable. To achieve this flexibility, a structure is needed that employs multiple indexes, one for each type of field that may be the subject of a search. In the general indexed file, the concept of sequentiality and a single key are abundant. Records are accessed only through their indexes. There is now no restriction on the placement of records as long as a pointer in at least one index refers to that record. Two types of indexes are used. An exhaustive index contains one entry for every record in the main file. The index itself is organized as a sequential file for ease of searching. A partial index contains entries to records where the fields of interest lies. In the indexed file, variable length records can be employed. With variable length records, some records will not contain all fields. When a new record is added to the main file, all of the index files must be updated. Indexed files are used mostly in applications where timeliness of information is critical and where data are rarely processed exhaustively. Examples are airline reservation systems and inventory control systems. The direct or hashed file. The direct or hashed file exploits the capability found on disks to access directly any block of a known address. As with sequential and index sequential files, a key field is required in each record. However, there is no concept of sequential ordering here. The direct file makes use of hashing on the key value. Direct files are often used where very rapid access is required, where fixed length records are used, and where records are always accessed one at a time. Examples are directories, pricing tables, schedules, and name lists. Pause the video and give me the answer to this question. What is a hash function with respect to searching? So what did we learn today? We discussed functions on files. We explored file structure. We discussed operations on files. We understood file management system and explored its objectives, architecture, functions, and performance issues. We discussed file organization. We explored different types of file organization. In the end, some things to do for you. Read the book, find the answers to the tasks that I've set you, and submit them to me when I ask you. Note your questions relevant to this lecture and keep them with you and put them up in the online session. And if you have any suggestions, email them to me. Take care. Allah Hafiz.